All right, last class period. The main topic was talking about these two matrices, where you had a cost matrix for uniforms plus and sporting supplies, and it gave costs of small, medium, and large jerseys. 28, 36, 41, 34, 35, and 36. So these are all in dollar amounts. You have to remember that they're in dollar amounts. And then you had a quantity matrix where we had small, medium, and large quantities for the Zephyrs, the Flyers, and the Pioneers. So those are the teams. And they had all these quantities. So this was 6, 11, and 3, 6, 4, 10, 9, 6, and 5. And what the exploration should have pointed out yesterday was that dimensions matter when we're multiplying these. So this cost dimensions, it goes columns by rows, so this would be a 2 by 3. And what would this quantity one be? A 3 by 3. So when you're asked to multiply these, what order would you have to go in? Do you recall? That's how dimensions are labeled. Shut the laptops. You don't need them. What's the way you have to multiply these? Kaylee?
Like, so first row times the first column.
Okay, I know that, but in what orders? And for instance, can I do quantity times cost or cost by quantity? Cost by quantity? And how do you know that?
Because it has the same number of rows and columns.
It does. The cost is a 2 by 3 and the quantity is a 3 by 3.
The cost column has the same number as the quantities rows.
Yes, these inner numbers have to be the same. So quantity by cost, the 3 by 3 times a 2 by 3 would not work. That would not work. Okay, and the resulting matrix. The resulting matrix had 2 rows and 3 columns. Will someone shut that door, please? And those 2 rows represented uniforms plus and sporting supplies, sorry. And the 3 columns we have would have been for Zephyrs, Flyers, and Pioneers. So what's the result? What do each of these entries mean? So I took the prices times the quantity. Price times quantity would give me what for each team? The total cost. So each of these entries would be the total cost matrix. So what I'm getting at right now is that you have to be careful and understand what each of what the context of these mean. Okay? And where you get the resulting rows and columns from. The rows come from the rows of that first matrix. Do you see that? Because there's 2 rows. And the columns come from the columns of that second matrix. Because the columns of that second matrix were the Zephyrs, Flyers, and Pioneers. And the rows were the original rows of the cost matrix. So this leads me into our toolkit of labels on matrices. I'll make that a little bit clearer. I'll be using the same example. So we took Uniforms Plus and sporting supplies with small, medium, and large jerseys multiplied by the small, medium, and large orders from these three teams: Zephyrs, Flyers, and Pioneers. So it works because it's a 2x3 times a 3x3. So we can multiply if the inner dimensions are equal or identical. And then the product of this, my rows come from this first one, which was Uniforms Plus and sporting supplies. And my columns come from this second matrix: Zephyrs, Flyers, and Pioneers, which gives me a 2x3 result. So we use our rows from the first matrix, columns from the second matrix. And after this, I'm going to talk a little bit about that contextual question on the CYU, because many of you did very, very poorly on it. And it was puzzling to me until I considered one thing. And can you give me a thumbs up if we're ready for me to go on here? Or still a couple writing? Okay. All right, are we good now? All right, shut the laptops again. All right, so on the CYU, the two matrices you had were number of toys made, and the toys were crabs, ducks, and cows, because these are little kid toys, for the 2 months of September and October. And our other matrix was time per toy. In minutes. And this is how long it takes each worker to make this. So the worker Elise and the worker Harvey for the crabs, ducks, and cows. So now, what are the dimensions on this left matrix right here? A 3 by 2, and this one is a 2 by 3. Okay, so let's consider if I took the number of toys made multiplied by the time per toy. First off, these inner numbers work, right? So we can multiply them. But the resulting product, we take our rows from our first matrices, which are crabs, ducks, and cows, and our columns from our second matrices, which are crabs, ducks, and cows. And while your calculator will give you numbers right here, these entries make no sense. The crabs is what that entry would be. The crabs, ducks. I don't even know what that means. If you switch the way they're multiplied, however, if we took the time per toy multiplied by the number of toys. So if we took the 2 by 3 multiplied by the 3 by 2. So our time multiplied by our number. The resulting matrix would be the rows from our time matrix, which are Elise and Harvey, and our rows from there, and our columns from the number of toys made in September and October. And I would have 4 entries. So I took the number of the time per toy times the number of toys made. So this would be the time required matrix in each month, for each month. So while you can get answers for both, the context of this answer does not make sense. The context of this answer does make sense, and it gives you vastly different numbers. So the big thing I'm trying to get at is that context matters. While it's super easy to use technology to get answers, you have to make sure those answers make sense. All right? Now, today, we're not going to be multiplying matrices, but our big idea or our big question that we're looking to answer is, how can a system of equations be represented and solved using matrices? So the first part of this investigation will focus on representing them, and the second part will focus on solving them. And this is using technology. So it is, yes, it's easy, but if you blow through this and don't take it seriously, you're not going to be very good at it, and you won't be able to do it. All right? So some of this stuff does take a little bit of effort. Okay? And it takes careful reading of what they prompt you to do. And we're doing each of the questions 1 through 7. And then when you get to the CYU that's on page 141, I didn't make this into a Google form. It's short enough that you're just going to hand it in on paper. Are there any questions for what we're doing today? Okay. That's all I got. Get started. And when you're done with this investigation, it should make your life easier when it comes to solving, because you now have a way to check answers for every system of equations you get. It's very, very nice, very useful.